Hello everyone, now we are going to be learning about ozonolysis of alkenes. So in this process, what basically happens is, we take an alkene, in this case we have taken an ethene. So when an ethene is gone through this process of ozonolysis, ozone will obviously be there. Alongside that, we take zinc and H2O. When the reaction starts to happen, what we see is, we will be getting two aldehydes in this case. But before that, how do we get that? Again, there's a simple process by which you can do your questions in the exams when they ask about ozonolysis. So basically what you have to do is, you have to draw a house-like structure. For example, we have ethene. First, oxygen bond, then write both of the carbon atoms alongside whatever is attached to them. For in this case CH2 and CH2, attach them again with another oxygen bond and form a ring type structure. Now what you got to do is, you have to just divide this. This is one group, this is another group, and now you can simply write what we get: HCHO plus HCHO. And now you'll be wondering what happened to this oxygen atom. This gets converted, like not converted, it gets mixed with zinc and forms zinc oxide. So this was one example. I hope it will be pretty difficult to understand for the first time, so I'll just take another example. In this time, let's take another example, and this time let's take an example in which we'll attach an alkyl group to it. For example, RCH double bonded with another carbon bond. In this case also, again the same things we are going to take: ozone, zinc and H2O. Let's form the tree-like, home-like structure, or you can also call it a ring-like structure. Oxygen bond attached to both the carbon atoms with whatever they're attached to. Simply you have to just write, then again attach them to an oxygen bond. Now break the bonds. As soon as you break the bonds, you get your answer. In the first case, we get an RCHO, which is an aldehyde, alongside HCHO, which is also an aldehyde. Just for your knowledge, I'm telling, this is known as a formaldehyde, and this is the general form of an aldehyde. And you can also get ketones by using this form. I'll show an example for that too. Let's take another example. In this case, we'll take a carbon bond which is attached to another carbon bond, but in this case what can we take? We'll take, this will be attached to one hydrogen bond, this will be attached to one alkyl group. Similarly, this will be attached to one alkyl group and another alkyl group. Again, same intermediates: ozone, zinc and H2O. Now we are gonna do the simple trick. Oxygen bond, then both the carbon atoms, what are they attached to? This is R, this is also, let's write it here, this is also R. This time this to an hydrogen atom and alkyl group. Now join the carbon atoms with an oxygen bond and then join the oxygen bond too. Now again break the bonds. This will be one bond, this will be another bond. Now what do we get in this case? We get R, C, R double bonded with an O plus R, C double bond O alongside an H. This in this case will be a ketone, general case. This will be an aldehyde. This is how you can get aldehydes and ketone by the ozonolysis of alkenes.